Hello guys, welcome back to another chemistry video. Today I'll be teaching you sig figs, the rules of sig figs, and how you can do them in calculation. So, to start with, there is a pretty long decimal here. And we see that there's 3 non-zero digits here and a ton of zeros. Let's break this down step by step. Firstly, any non-zero digit in any number is always going to count as a sig fig. This means that the 7, the 9, and the 6 are all going to be significant. So non-zero integers are always significant. So, nextly, we have a 0, 0, 0, 0 in the middle of this 7, 9, 6. These zeros are called interior zeros. You notice an interior zero when it is just zeros in between of two non-zero integers. In this case, it's going to be 9 and 6. Interior zeros are always significant. That means that you will have to count this as 4 significant figures. Next, let's look at these first 3 zeros. These 3 zeros are called leading zeros. And you can tell by my red color that these are going to be not significant. So I can show you more examples later, but just remember that any zeros that come before non-zero integers are not going to be significant. This includes this first little zero here too. And lastly, trailing zeros are actually sometimes going to be significant, and sometimes they're not going to be significant. So these are trailing zeros, all right, in black. So trailing zeros are only significant in a certain scenario, and that's when they're significant only when there's a decimal point. So what does that mean? That just means that when there's like 3.00, that means that these trailing zeros are going to be counted because there's a decimal point right there. As we see, this is going to be a decimal, a huge decimal. So that means that these trailing zeros are going to be significant. However, well, actually, you also count trailing zeros when there's overbar. So that's simply when it's like 10 to like 10 like that, or 10 to 6, 3, 0. So when there's an overbar like that, you count this trailing zero. We can do another example after that, but yeah. Otherwise, trailing zeros are not going to be significant. So make sure you remember that there are 2 possibilities here. So now let's look into some examples. Let's say I give you 1.54. How many significant figures does this decimal have? So here we see that there's no zeros, and these 3 integers are non-zero. Non-zero digits are always significant. That means that this has 3 significant figures. Sorry for my bad handwriting. I'll give you another example. Non-zero also counts when it's not a decimal. So if you have 45, this is 2 sig figs. Nextly, if I give you 0.02503, tell me how many significant figures are in here. Well, firstly, we know that non-zero integers are going to be counted towards significant figure. So here we have 1, 2, 3. And then we have an interior zero here. So to the screen, Interior zeros are going to be counted towards a significant figure. So that means that this is going to be 4. And then we have 2 leading zeros here, which are not counted. That means this has 4 sig figs. And interior zeros work in decimals, so that means this counts as a significant figure. This has 3 sig figs. And if there's a non-zero that's before the decimal and the interior zeros are after the decimal, remember that this also counts. So that means these count as 2 sig figs, 1, 2, 3, 4, 5, 6. 6 sig figs. Great. Now let's look into the trailing zeros, which I said were kind of wonky. So let's say we have 1.050. Let's start with what we know. We have 2 non-zero numbers here. So that means that there will be 2 sig figs contributed by this 1 and the 5. And then we have an interior zero right there, meaning that this will also be counted. So that's going to be 3. Then we have a trailing zero. How do we know if this is counted or not? Well, if you remember what I said before, whenever that the number is a decimal or they carry over bars, the trailing zero is going to be counted as significant. That means that this is also going to be significant. So 1.050 has 4 sig figs. So trailing zeros are pretty important, especially when you're dealing with scientific notation. Let's say you have 1.00 times 10 to the third. Well, firstly, we have 2 trailing zeros right here and 1 non-zero digit. So this counts as 1. And then, since this is a decimal, you have 2, 3. But since that has 3 sig figs, what about this 10 to the third? Do we count that as 1 sig fig because there's a 10? 3 sig figs? We actually don't count it my bad. We actually don't count it at all. When we actually multiply this out, we see we get 100, right? Not 100, 1000. 1000 has 1, and these are actually not counted. That means that this has 1 significant figure if you expand it into 1000. So keep that in mind when you're dealing with significant figures. In scientific notation, the 10 to the power of whatever is not counted. So this will add 3 sig figs. And finally, remember that over bar, just 10 to the power, or no, 10 over bar, just repeating, so that means this will also have 2 sig figs. The trailing zero is counted. Okay, now let's look into significant figures and calculation. So let's say we're dealing with addition and subtraction. So in both of these scenarios, let's say we have 2.0345 plus 0.07 plus 2.9975. And I want you to find the answer. So how do we know how many significant figures the result has? So for addition and subtraction, you need to remember that the result will have the same number of significant figures as the number with the lowest number of decimal places. So that means that the number with let's say we have 3.05, that has 2 decimal places, just the numbers that are after the decimal point. So that means that that has 2 decimal places, and that's how many decimal places the result will have. And it's kind of hard to understand when I write it down, but just look at this example. So let's first count the number of decimal places that are in our little additional thingies. So here we have 1, 2, 3, 4. Also we have 4 dp. We have 1, 2, 2 dp, 1, 2, 3, 4. And remember, these are just decimal places, so it's the number sets after the decimal point. Here we know that 2 is obviously less than 4 and the other 4, so that means that our answer will have 2 decimal places. So once we add this up, we get 5.4125, and using this rule, we know that the answer will be 5.41, and that will be the correct answer. And to specify, this ends up having 3 sig figs. So remember that when you're doing addition and subtraction, it's about the number of decimal places, which will determine the answer. However, when you're dealing with multiplication and division, and also keep in mind that I'm not going to do division just like how I'm not going to do subtraction, because it's literally the same thing. You're doing multiplication and division. Let's say we have like 5.02 times 89.665 times 0.10. First, you're going to use the number with the lowest number of significant figures. So for multiplication and division, result uses lowest number of significant figures. So what I mean is that's going to be easier to understand when I actually solve this. First, count up the number of significant figures in each of the things that you're multiplying. So here we have 3 sig figs, because there's 2 non-zero and an interior. Here we have 1, 2, 3, 4, 5. Here we have this 0 is not counted, 1, and then we have a trailing 0. This is a decimal, so that means this is also counted. This will have 2 sig figs. So we're using the lowest number of significant figures. So once we actually solve this, we'll get 45.0118. So when we're doing the number of significant figures, we're going to have to round out to the lowest number of significant figures, which is 2. So that means that our answer will have just whatever's the first 2 sig figs. Here that's 45, so that's just going to be 45 is the correct answer. Let's just do the division here for extra practice. Let's say we have 5.892 divided by 6.10. First, count the number of significant figures. 1, 2, 3, 4. Here we have 1, 2, 3. This is trailing, and it's a decimal, so it will be counted. So once we actually divide this, we'll get 0.96590. And we know that according to our rule for multiplication and division, with the result we'll use the lowest number of significant figures, which is 3. So that means that if we count here, we'll have to round up to 3 significant figures. 0 is not a significant figure. That means we're going to use 965 in our answer. Therefore, we'll have 0.965. But we actually have to round it. I forgot to do that. When you're dealing with sig figs, you can't just leave this 5 like that. So if it ends where like a decimal point can be rounded, in this case we have a 5, 9 here, that means that this 5 can be rounded up to 6. So just remember to always round. Something I forget sometimes. So we're going to round off to 3 sig figs. So just make sure not to write like 966 because these two numbers are completely different. Just put 0 there. Yeah, so that's it. I hope you learned a little bit something new. I'll see you next time.